So when we're dealing, Friday we were dealing with adding and subtracting. We were breaking stuff down and combining like terms, and there's going to be some similarities today, but we're not necessarily going to be looking for like terms, but we're still going to be breaking stuff down. That's kind of a theme for everything that we're doing here. Stuff, we did adding and subtracting radicals. Right there. That's stuff. So for now, we are going to be here at the bottom of page 2 of the notes, right below the adding and subtracting, for multiplying radicals. So it says step 1, multiply the outside numbers together and multiply the inside numbers together. Okay, we can do this. So let's see here. Multiply the outside numbers together, 10. Multiply the inside numbers together, 18. Okay, that's always going to be the first step no matter what. Then step 2 is a maybe. If possible, reduce the radical. So here we come again. Grab one of these. I'm just going to do this for our reference here. If you need to flip back and forth somewhere, you can use the paper that I'm going to have up here. So here comes that list of perfect squares again. Try not to go overly crazy here. And if you did this when we were initially doing it over on page 1, we'd also written what the square root of each of those were if we ended up having to break any of these down. So if you didn't do that initially, when I update all the notes as posted, we'll want to get that. So, just like we were doing before, when we got to this number trying to figure out what the radical, we'd look at the numbers that are less than 18 and see if we could divide any of them in. Now, maybe you're getting to a point that you are so comfortable with this that you kind of know which ones might work and which ones just aren't gonna. But here, okay, 9 went in, so 9 and 2. Again, we got colors in the back, if that would be helpful. But the only one of those that breaks down is the one that's in the list, and it's the number right above it. So the square root of 9 becomes 3. The 2 is not in our special box there, so it stays the way it is. In jail, it's right, it's in radical jail. And so once we've taken care of that, the values that are outside now, we can still just multiply together. So it's a lot of the same things that we've been doing before, just now there's not like terms at the end. We multiply, we're done. So in that way, this is going to go faster, which is always a nice thing when we can get something that goes a little quicker. And so as we keep looking at these, let me bend this way. Sometimes you're like, well, what if there's no numbers on the outside? Okay, we'll just do the numbers on the inside. 5 times 7 is 35. And I start to look. Now this time I go looking, and I'm like, all right, so 35, there's my numbers that are less than 35. All right, let's try this. 35 divided by 25, no. 16, no. Uh-oh. 35, no. 35, 9, no. Hardly none of them went in. Did I do something wrong? No. Sometimes you're just done. So if you go through your process of trying to divide those perfect squares in and none go in, you can't do anything. We can't use different numbers. We can't use 7 and 5. We can't use any other pairs. It has to be those. So that's just done. What if I'm multiplying? There's only one number on the outside. Write that number down. we're still going to multiply the two radical numbers together. So 5 times 10 is 50. Anybody got anything to say about what's going to go into 50? Yep, 25. So that's going to go down to that, because if we do 50 divided by 25, we get 2. So 25 and 2. But again, the 25 being in the perfect square club, it's going to get out. It's going to be 5. Square root of 2. But don't forget about this negative 3 that's hanging out. Now, we haven't had to do anything with it up until now. And we just multiply those together. And we're good. So multiply them, break them down if you can, and then go that route. Now this last one, this gets interesting. I'm going to teach you a trick here. So you're like, okay, well, how's this work? So this squared that's out here, since there's parentheses around it, that squared's going to go to both of these. So I have got 2 to the second power and the square root of 11 to the second power. Check this out. So 2 squared, I can do that in my calculator. 2 times 2 is 4. But here's the trick. We're going to make this simple. Square and square root are opposites. So whenever you see square and square root together, they just cancel out and leave you with what's underneath them. So I do not have to square the 11. If I did, just to let you see, actually I'll do it on here because I want it to show up on the video too. If I'd have gone ahead and squared the 11 and gotten to the square root of 121, if I put that in my calculator, it's just 11. I'd have gotten here anyway. But that's the only time we get away with that. And then I can multiply the two numbers together. Because neither of them are underneath the radical. They're both just the numbers on the outside. Because here, if I squared that 11 and put it under the radical, we found out when I get to the end, if you take the square root of that number, you just get this number back anyway, and it's not in the radical anymore. Because 11 times 11 is 121. The radical would go away anyway. So that's one odd circumstance that we're going to run into. But other than that, that's how these are going to work. And as we've seen multiple times so far, and we'll get that back up in a minute if we need to here, as we flip over to the third page, so we're going to flip over your notes one time here today for one problem. For area, reminder on area is length times width. So we're just multiplying these together, just like we've been doing on all of these. And so now we're back to the first couple of problems that we did. So if I needed to look, I could. But I'm going to multiply the numbers together that aren't under the radical. And then the numbers that are under the radical, I'm going to multiply those together as well. And you know what's coming next. Here comes my list. And I know how quick some of you are with your fingers. I've seen some of you play the phone game here. So I know this would not take long. Ooh, is this going to be one where we get none? Last chance. Oh, last chance. We got there. So 4 and 15. Square root of 4 is 2. But the 15 is still lurking. So those got to get multiplied together. And that's going to be my area. So not a whole lot of difference from some of the things we've been doing before. Actually, I think that's shorter than the add and subtracting part was when we were doing that back last time we were together. So that's the end of new notes before this next quiz. So, as we normally do in these situations, we have got some practice. So we're going to be looking at 9 and 10 here. And as we have also seen in the past, our examples are going to be pretty darn similar here. So examples 1 and 2, real close to what you're seeing on these level 1s. Even when you get to level 2, we're not looking at a whole lot that's different. Like they're right there. There's not one in here that's not similar to the examples that we were doing in those first 4 problems. So that, don't have to mess with a whole lot. Now, when we get to the back, that might be a little different of a story. Because we know how we normally run around here. Oops, almost went to the puzzle already. Okay, area of the figure. Looking just like that page 3 example. Just like when we were messing with these. Same idea. Okay, so we've got that. Now, if we start to throw some weird in, some of you are like, oh no. We don't need to do no weird. Okay, let's talk through weird. So I look to distribute. This is the exact same thing that we did. Let me do a little folding here, just a second. This is just like this. It's the same idea. Multiply the outsides. Multiply the insides. Then multiply the outsides. Multiply the insides. I know with the colors this got a little crazy. So the question now becomes, can I break either of those down? Can I get this further where I might be able to put them together? Well, that first one, that doesn't break down, so that one's done. 14, I can still try. 9, no. I can try 4, no. Okay, so since they don't break down anymore, that's done. These have to be the same radical for me to be able to add or subtract. Because we're not multiplying anymore, we're adding. So that's as far as that one can go. So sometimes it may look bad, but it's not really going to be as bad as you think. And so the last hint I will give, before I get attendance in and start floating around a bit, is just a reminder. Perimeter, we're just adding up the sides. We're combining like terms. Nothing fancy. That's a review. No multiplying there. And then area is length times width. Again, no radicals involved. Just multiplying the bigs and adding the littles. And we've done 3 days in a row of system of equations, so I'm going to let you play with that. But if you have a question, I'm absolutely willing to come by and help out. But tomorrow we will do all things radicals. Simplify, multiply, add, subtract, mix it together, and kind of start getting a feel for this as we start getting ready for this last quiz of quarter number 3 on Thursday before we head down the home stretch. So again, play with these, do them, but hang out.